All right, in order to get the answers, I was able to get the answers he had in the back. Well, let's walk through them. Number one, right? Basically, I have to take the derivative of the outside first, which would be 23, same inside, minus x to the 22nd, right? And then take the derivative of the inside, which will be, if I bring this down, negative 10 thirds when I put 2 thirds and 5 together, x to the negative 5 thirds, I subtracted 1, right, minus 1. So that would be the answer here. This one will be, I'm going to write this as x to the minus 1. So the derivative of sine is cosine, same inside. Then take the derivative of the inside, which will be 6x, all right, minus, I bring the minus 1 down in front, it becomes plus x to the negative 2. That's all that is. All right, this one is, first, the derivative of the natural log is 1 over what's inside there, right? 1 over x, and this right now is x, times the derivative of the inside, where the derivative of the arctan is 1 over x squared plus 1. Those you just have to memorize. Finally, let's do some implicit differentiation for dy dx. All right, so I have to do a product rule here. The derivative of x is 1 times this plus x times the derivative of y, which is 2y dy dx, plus the derivative of sine is cosine dy dx, plus the derivative of x to the third is 3x squared. Derivative of 10 is 0. So what I'm going to do is move over the two terms that don't have a dy dx in them. So I'll be bringing over, subtract over negative 3x squared minus y squared. And then that leaves me this on the side, and I factor out dy dx, and then divide everything by what's left. So I divide by 2xy plus cosine y. Right? Because this would end up being 2xy dy dx plus cosine y dy dx. So I'm going to factor out dy dx. Whoops, didn't mean to do that. I'm left with 2xy plus cosine y. And then I divide by it, right? All right, so those are the 4 derivatives he had there for you to do. Now, these are the multiple choice. It says, use the graph of f prime above to determine if x is increasing or decreasing on this interval from 3 to 4. So from 3 to 4, what is the function doing? Well, look at this. The derivative is less than 0, isn't it? The derivative itself is negative. And if the derivative is negative, the graph is decreasing. It says, use the graph of f prime again to determine which of the following are local maxima of f. Well, we know we have critical points here, 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 and here, wherever the derivative is 0. What we do need to know, if it's a local maxima, then it had to be increasing, 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 and then decreasing. So the graph of the derivative should be positive here and negative here. Well, this one's positive and negative, that works. This one does not. This is positive, negative, and that works. So it should be 1 and 3. Or I'm sorry, 0 and 3. Alright, so now it says, consider the following limit. If we put in x, if we substitute in, we're going to get infinity raised to the 1 over infinity, which is 0, isn't it? That's an indeterminate form, of course, but that's the form of the limit, and we'd end up having to do something else, wouldn't we? I'm not sure how we'd get that into L'Hopital's rule if we could, but all right. Next, the graph is shown here. Suppose we want to estimate negative 1.5. So I'm just going to say, all right, here's about 1, here's about 1.5. Suppose we want to estimate negative 1.5 by using tangent line approximations. Which yields a better approximation? Well, look at this. the tangent line at -2 is 0, where the tangent line here is about like this, 1.5. So I believe the one at x equals to 1 is better, because at here it's all 0. That's the only thing we get was 0. Right, this lighthouse one was a little different, but what they're trying to do is they would need this amount x to calculate the speed, because when this thing moves around, that's actually the radius of the circle it's building. So it's best to differentiate which of these things is really x. X equals theta sine. No, we don't want r. We want this, because we know this number here. If we used r, not only was that an unknown, that's an unknown, right? So we want to differentiate this, because that's not an unknown. And we're not going to use these, again, with two unknowns. You'll see when we did these problems on the last sheets, we did use tan, as we knew one of these to get the other. Okay? 10 says, if p double prime, or if the second derivative of p is 0, then the graph must have an inflection point. Well, that's false. It might have an inflection point, but you have to check it, right? You have to check that at things very close to p. You'd have to check it at a number over here and a number over here, something very close to those. If f is continuous and has a local maximum, it will occur where the first derivative is 0. Well, it might occur there, or where the first derivative does not exist. Don't forget that part of it. So this is false. 12. If f is continuous and has a local minimum, it will occur at a critical point. Yeah, right? These two are called critical points, where the derivative of f of x equals 0, and where the derivative equals 0 or does not exist. So that is true. These are where you find the critical points, aren't they? All right. If f of x equal x squared does not have a global... Oh, it doesn't. Let's look. Here we have an interval, 0 to 2. If we draw this thing, actually it looks like this. This open interval from 0 to 2. It does not have a global minimum. I said maximum. It does not have a global minimum, because the minimum point's happening as we approach 0. So they say that's not a global minimum. On an open interval, it has to occur where a critical point is this, and it doesn't here. A critical point of f must be a local maximum or minimum. Now that, oops, I'm sorry. This does not. That's true, right? We said it doesn't. A critical point of f must be a maximum or minimum, and that's no. It could be, but we have to test. It could be one of those things that looks like this, where it comes up and does that. So it does have, right here, it does have slope of the tangent line equals 0. So we have to test it. That's not necessarily true. All right. Let's look at, actually I'm going to do this so far. I'll make another one with the rest of it, okay?